In today's class, we will be seeing certain aspects of lasers, such as the applications, characteristics, and what are Einstein's coefficients. Now, coming to the characteristics of lasers, some of the special properties which distinguish lasers from ordinary light sources are their directionality, high intensity, monochromaticity, and they are coherent. Now this slide over here shows what is directionality. If you see in the slide, white light source emits all colors in different directions. Even if you take a monochromatic source of light as shown in the picture B, it is monochromatic but not directional. There is divergence. Whereas if you see CBET, laser light source, it is highly directional in nature. So now this laser beam, as you would see, it has got some amount of divergence. In the diagram you would see we have taken 2 points 1 and 2. At point 1, let D1 be the distance from the laser source and R1 the radius of the what you see over here. Likewise, at the point D2, the point 2, let D2 be the distance and R2 be the radius. The directionality of laser beam is expressed in terms of angle of divergence. How do you measure this angular divergence or angular spread? It is equal to R2 minus R1 by D2 minus D1. As I have already told you, D1 and D2 are the two distances and R1 and R2 are the radii of the beam spots at distances R1 and R2 respectively. Laser light has less divergence, which means that laser light has more directionality. What about intensity? In case of lasers, light is a narrow beam and its energy is concentrated within a small region. The concentration of energy accounts for greater intensity of lasers. What is monochromaticity? Single color. So this picture shows an ordinary bulb and a laser light. Ordinary bulbs gives multiple color. It is not monochromatic, whereas laser light gives out a particular color, so it is highly monochromatic in nature. This picture shows you what is incoherent light and what is coherent light. The first picture is incoherent light, whereas the second picture shows what is coherent light. This diagram also shows you once again the difference between a coherent light and an incoherent light. Now, with respect to coherence, if any wave appears as pure sine wave for long time and infinite space, then it is said to be perfectly coherent. Practically no wave is perfectly coherent, including lasers. But compared to other light sources, lasers have high degree of coherence because of all the energy is concentrated within the small region. There are two independent concepts of coherence: temporal coherence, that is coherence with respect to time, and spatial coherence, that is coherence with respect to space. Applications: lasers have n number of applications, as this picture shows you. Okay. Coming to communication application of lasers, lasers are used in optical communications due to large bandwidth. The laser beam can be used for the communication between Earth and Moon or other satellites due to narrow angular spread. They are used to establish communication between submarines, that is underwater communication. In the case of medical application, they are used for removal of cataract, used to detect and remove stones in kidneys, used to detect tumors in brains. Application in industries for welding, for cutting and for drilling, among other applications. Now coming to what is Einstein's coefficients. Einstein's coefficients gives you a relationship between the spontaneous emissions and stimulated emissions. So we would see in a collection of atoms, all three transitions process occur simultaneously. That is absorption, spontaneous emission and stimulated emission. In absorption, what happens when light energy is given? The atoms can go from the lower energy states to different higher energy states. Spontaneous emission means particles in the higher energy state come down by themselves. Whereas stimulated emissions means particles in the higher state come down to the lower energy states when external radiation strikes them. Now to derive this, let us assume N1 is the number of atoms per unit volume with energy E1 and N2 number of atoms per unit volume with energy E2, and U nu is the energy density of interacting photons. That is, when we give external energy in the form of photons, they will go and interact with the atoms which are in the ground state. Okay. When these photons interact with atoms, both upward transition and downward transition occurs. What is the upward transition? Absorption. And what is the downward transition? Stimulated emission. Here you got to understand that spontaneous emission do not require any photons, external photons. Now, upward transition equation is stimulated absorption rate is equal to N1 U nu B12, where B12 is the Einstein coefficient of stimulated absorption. Downward transition, the excited atoms may come down either by spontaneous emission or stimulated emission. Downward transition, by spontaneous emission, the equation is N2 A21, where A21 is the Einstein coefficient for spontaneous emission. They don't require external energy. So U nu is not present in that equation. By stimulated emission, rate is equal to N2 U nu B21, where B21 is the Einstein coefficient for stimulated emission. Under thermal equilibrium, number of upward transition is equal to number of downward transition per unit volume per second. So here we have written 2-1 on one side and 1-2 on the other side. 2-1 means from higher levels to lower levels. B12 means from lower level to the higher level. From equation 1, we can get a value for U nu. Dividing by B21 N2 for all the terms, you arrive at this expression for U nu. Also we know that N1 by N2 is equal to exponential of h nu by kt from Boltzmann distribution law. So we substitute the value of N1 by N2 in the above expression. Now, the above equation must agree with Planck's energy distribution radiation formula, which is U nu is equal to 8 pi h nu cube by c cube into 1 divided by exponential of h nu by kt minus 1. When you compare expression number 4 and 5, we arrive at B12 is equal to B21 and get A21 by B21 is equal to 8 pi h nu cube by c cube. These coefficients A21, B12 and B21 are known as the Einstein's coefficients. So Einstein's coefficient gives us a relationship between the spontaneous emission rates and stimulated emission rates. Okay. A means what over here? A means from higher, spontaneous, and B means stimulated. So for laser action to take place, though both are present, spontaneous and stimulated, stimulated should be much greater than water spontaneous emission. These are what are known as Einstein's equations, and you got to learn them thoroughly.